All right, Unit 7, Trigonometry. Classify the triangle form by the side lanes as acute, right, or obtuse. All right, so for this, we want to see how c squared compares to a squared plus b squared. So how the longest side compares to a squared plus b squared. If c squared is greater than, it's obtuse. If it's less than, it's acute. If it's equal to, then it is a right triangle. So let's go ahead and start with number 7. Oops. So for number 7, so the longest side is 9. So how does 9 squared compare to 6 squared plus 8 squared? So 81, 36 plus 64. So since 81 is less than 100, then these side lanes would make an acute triangle. Okay, if it's less than, it would make an acute. Okay, number 8. How does 5 squared compare to 4 squared plus 2 squared? 25, 16 plus 4. So how does 25 compare to 20? Well, 25 is greater than 20, so this would make an obtuse triangle. Okay. Number 9. So you have some radicals here. So you want to use a calculator so you could see which number is bigger. So you want to see what 6 times the square root of 3. Put that into the calculator and you get 10.39. So that's actually the biggest number. Okay. So it's going to be 6 square root of 3 squared. How is that compared to 10 squared plus 2 square root of 2 squared? Okay. So this is actually 6 squared is 36, and then the square root of 3 squared is actually just 3. So 36 times 3 on this side of the question mark. 10 squared is 100. 2 squared is 4, and then the square root of 2 squared is 2. Okay, so this one has more steps. 36 times 3 is 108. And then 100 plus 4 times 2, which is 8. So 108 is equal to 108. So this one is a right triangle. Okay, so if it's equal, it's a right triangle. Okay, number 10. 20 squared, 15 squared plus 15 squared. So 400. 15 squared is 225 plus 225, that's 450. So 400 is less than 450, so this one is acute. Okay, for number 11, 3 squared is 2, that's the biggest number. And then 3 squared plus 3 squared. So this is 9 times 2. And this is 9 plus 9. So 18 is equal to 18. So this is a right triangle. And then finally for number 12, let's see what's 3 times the square root of 55. Okay, that is 22.2. So that's the biggest number. How does that compare to 13 squared plus 18 squared? So 3 squared is 9. Square root of 55 squared is 55. 13 squared is 169. 18 squared is 324. So this side is 493. And then 9 times 55 is 495. So it's slightly bigger than 483. So this is going to be an obtuse triangle. Next part, find the value of x. Write your answer in simplest radical form. So we're going to use some trigonometry here. Okay, remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay. You could use that. When you have a right triangle, you could use Pythagorean theorem. And you could also use special right triangles. So special right triangles. Okay, we have 45, 45, 90 triangles where the hypotenuse is the leg times the square root of 2. And we have the 30, 60, 90 triangle where the hypotenuse is the short leg times 2, and the long leg is the short leg times the square root of 3. Okay. So all of this all of these you can use when you have a right triangle. Okay, for number 19, okay, we have two side lanes, we have x, we don't have any angles, so you might want to use Pythagorean theorem. So 6 squared plus 6 squared is equal to x squared. So 72 is equal to x squared. So x is the square root of 72. And you want to simplify that. 72 is the same thing as 36 times 2. So 6 square root of 2 will be your answer. Okay. For number 20, it's a 30, 60, 90 triangle. So you could use the special right triangles. You could use those little formulas there. You actually have the hypotenuse, okay? And to find the short leg, so remember the hypotenuse is twice as big as the short leg. So that means that x has to be 7. Okay. And for 21, again, you have a 30, 60, 90 triangle. let's see, you have the hypotenuse. You need the hypotenuse. You have the short leg. So all you have to do is multiply it by 2. So the hypotenuse would be 8 square root of 3 times 2, which is 16 square root of 3. Okay, next. Again, we're finding the value of x here. This time our angle is 54 degrees. So we cannot use special right triangles anymore. Now we have to use trigonometry, SOHCAHTOA. Okay, so we need to figure out how these side lanes are related to the angle. X is opposite of 54. 32 is adjacent to. So the trig ratio that uses opposite and adjacent would be the tangent. So the tangent of 54 is equal to x over 32. And to solve for x, we're going to cross multiply. So x is equal to 32 times the tangent of 54. And put that into your calculator. Make sure your calculator is in degree mode. And you should get 44.04. Also, oh, sorry, it says round to the nearest 10, so 44.0. For 25. Okay, so we have the 25-degree angle. Oops. Sorry. Okay, we have opposite, and we have adjacent again. So the tangent of 25 would be x over 20. Again, we're going to cross multiply. So x is equal to 20 tangent of 25. So it's going to be 9.3. And then for 26, 10 is opposite, x is adjacent. Okay, so check out this setup here. So the tangent of the 38-degree angle is 10 over x. Okay, this is a little bit different. When you cross multiply, you get x tan of 38 is 10. X is not by itself yet. You have to divide by the tangent of 38 to get x by itself. Sorry about that. Okay. We divided by the tan of 38. So now you're going to punch in 10 divided by the tangent of 38 degrees. And that should give you approximately 12.8. Okay, so for 30, 31, and 32, solve the right triangle, round decimal answers to the nearest tenth. Okay, so when it says solve the right triangle, so here you have to give me all 3 side lanes and all 3 angles. So there's 6 items you have to make sure that you give me to solve the triangle. Okay. Let's see. So for number 30, out of those 6, we have 3 of them already. Okay. We have this side lane here is 15. This side lane here is 10. And this angle here is 90 degrees. So we have 3 out of the 6 already. We still need to find the other 3. Okay. Let's start off with the other side lane. Let's say we call this x. There's many ways we could solve for it. Since it's a right triangle, we could actually use Pythagorean theorem. So x squared plus 10 squared is equal to 15 squared. then subtract 100 from both sides. And then you're going to find the square root of 125. So x is equal to the square root of 125. Okay? It doesn't have a perfect square root, but you could simplify it because 125 is 25 times 5, so it's actually 5 root 5. Okay? So x is equal to 5 root 5. So we have all three sides. Now we need to find the other two angles. Okay. To find the other two angles, we're going to use the trig ratios. We're going to use the inverse of the trig ratios. Let's start off with angle. Start off with angle A. Angle A. So for angle A, the 10 is adjacent to it, and the 15 is the hypotenuse. So the trig ratio that uses adjacent and hypotenuse is the cosine. So the cosine of angle A is 10 over 15. Okay, I just stated it. Okay, to figure out what A is, to figure out the angle, I'm going to do the inverse. So A is equal to the cosine inverse of 10 over 15. So this is the inverse button on the calculator. So second cosine 10 over 15, that would give you the angle of 48.2 degrees. Okay, that would be angle A. For angle B, I could use the 10 and 15 as well, but notice that for angle B, the 10 is opposite to it. 15 is still the hypotenuse, but the 10 is opposite. So the trig ratio that uses opposite and hypotenuse is the sine. Okay, so make sure you're using the right trig ratio. So the sine of B is 10 over 15. So B is equal to the sine inverse of 10 over 15. Which is 41.8. Okay. Notice that these two numbers here, they add up to 90 degrees. Okay, they have to add up to 90 degrees because there's 180 degrees in the triangle. 90 plus the 90 degree angle, that's 180. Okay, and that's like another way you could check your work. And I solved it. Okay, so 90, 48.2, 41.8, those are the three angles. And then 10, 15, 5 square root 5, those are the three sides. That's how you solve the triangle. You find all 6 items. Okay. 31. Okay. We have 37 degrees, we have a 6, and we have a right angle. We could start out by finding angle L by triangle sum theorem. 90 minus 37 is 53. This has to be 50 degrees by the triangle sum theorem. Okay, so we have the angle part. Now we have to find the other two sides. So let's call this one x. So to find x, I'm going to use the 37. X is the hypotenuse. The 6 is adjacent to the 37. So the trig ratio that uses adjacent and hypotenuse is cosine. So the cosine of 37 is 6 over x. So we're going to cross multiply. So to get the x by itself, we have to divide by the cosine of 37. 6 divided by cosine of 37, 7.5. So x is 7.5. Call this other part y. Okay, call it y. Again, I'm still going to use the 37 and the 6, but y is opposite. So the one that uses opposite and adjacent is the tangent. So the tangent of 37 is y over 6. Okay, when I cross multiply, I get 6 tangent of 37. Oh, so I'll go straight to the calculator. 6 times the tangent of 37. That is 4.5. 4.5. Okay, side length, side length, side length. Angle, angle, angle. That's complete. Okay, 32. For 32, we have two side lengths. To find the third one, I'm going to go with Pythagorean theorem. So to be called this, let's call this A. A squared plus 18 squared is equal to 25 squared. So plus 324 is equal to 625. Subtract 324 from both sides. So a squared is 301. So a is the square root of 301. Okay, and that doesn't simplify it. So it doesn't simplify. So we just leave it like that. A is the square root of 301. Okay, we have three side lengths. Now let's find the angles. Okay, we already have angle y. Angle y is 90. So angle z, and to avoid using that square root of 301, the 18 is adjacent and the 25 is the hypotenuse. So let's go use cosine of z is adjacent over hypotenuse, so 18 over 25. So the cosine, so z is equal to the cosine inverse of 18 over 25. And that is 43.9 degrees. Okay. And then for x, 18 is opposite, 25 is hypotenuse. So the one that uses opposite and hypotenuse is the sine. So the sine of x is 18 over 25. So x is equal to the sine inverse of 18 over 25, which is 46.1 degrees. Okay, so notice that 43.9 and 46.1 add up to 90. So angle, 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 side, side, side. Okay, we solved the triangle.